Civil Engineering Introduction. This film shows the construction methods, sequence, and resources used to construct various civil engineering projects. Civil engineering deals with the design and construction of roads, bridges, seaports, airports, canals, railways, pipelines and more. Roads, motorways and bridges. Shown is the general construction sequence, methods, and equipment used to build a road: setting out, stripping vegetation, excavation, install underground utilities, granular sub-base, asphalt pavement, road markings, street lights, and signage. Earthworks include excavation, trenches, haulage, grading, backfilling, filling and compaction. This 3D animation shows a motorway constructed on a high embankment where the underlying soft ground had to be strengthened using stone columns and surcharging. 3D animations are ideal to demonstrate the series of activities and equipment necessary to carry out a project. Bridge construction. These slides show the construction sequence with a timeline for a 4-span road bridge with an in-situ post-tension deck. Included are photographs of the activities. Airport runways. The asphalt mixture is laid with 2-tracked pavers, equipped with extending screeds, tamper, vibrators, auger, and conveyor. The pavers work in echelon, in a staggered formation, producing a 15-meter wide mat. Level control is maintained by 2 string lines as a grade reference system for the lead paver, and a matching shoe and 1 string line for the following paver. The pavers operate using an automatic screed control, which controls the screed height using the string line or the matching shoe as a level and line reference. Seaports, quay walls, and breakwaters. Dredgers are marine vessels used to excavate and fill underwater. Trailing suction hopper dredgers are used to dredge soft and loose soils, gravels, and silts. There are 2 suction drag heads, which are lowered onto the seabed. These move with the dredger along the seabed. The dredged material is sucked and pumped either into the hopper or through a floating pipeline to a discharge area. Cutter suction dredgers are used to dredge hard soils by cutting and breaking up the soil using a rotating head at the end of a pipe which is lowered onto the seabed. The fragmented material is sucked and pumped either into a hopper barge or through a floating pipeline. During operation, the dredger is anchored by a spud, which allows the cutting head to swing in an arc. Split hopper barges are used to transport dredged or fill material which is then discharged through openings in the bottom. Barges are long flat-bottomed water vessels used for transporting materials and/or equipment such as cranes and excavators. Barges can be self-propelled or towed by tugs. Jack-up barges are hulls with vertical legs on which the hull can jack itself up. Spud barges are vessels with vertical legs, usually tubular steel pipes, that are lowered into the seabed to anchor the barge. For setting out purposes, high towers that sat on the seabed and extended above the water level were used. The quay wall is constructed using precast reinforced concrete hollow blocks that weigh up to 160 tons. The blocks were cast in the on-site precast yard and loaded onto barges at the temporary loading jetty that had a 200-ton capacity gantry crane. A screeding frame that extended from the seabed to above water was used to place the bedding layer to the correct level. Up to 22 blocks were placed per day using a barge with a crane. Part of the coping beam was cast in situ in sections using concrete pumps positioned on the reclaimed land behind the quay wall. The breakwater is constructed using core rock, rock armor, precast armor units and geotextile. The core rock is placed using split hopper barges in deep water and by lorry tipping and dozers in shallow water where the risk of slippage is minimal. The precast armor units are placed using crawler cranes fitted with a real-time visual aid system that enabled 70 placements per day. The wave wall is cast in situ in 6-meter-long sections. Precast yard. Full-scale sample castings are constructed to demonstrate and document that all the requirements of the concrete and the execution of the work are fulfilled using the actual methods and performed by personnel that will carry out the future castings. One concrete component of each type is produced for approval. The approved castings were retained in a dedicated area for quality assurance purposes. All works were inspected in accordance with the Inspection and Test Plan, ITP, on an ongoing basis, in accordance with the Site Project Quality Plan. The ITP set out in matrix form the sequence of inspection steps, the governing document, specification, standards, the standard to be achieved, the persons witnessing and the supporting documents to be produced. Oil and gas pipelines both onshore and offshore. Onshore pipeline, the construction sequence is, set out the pipeline route, strip and grade the ground, string out the pipes and bends, weld the pipes together, excavate the trench, lower the pipe string into the trench, backfill the trench and reinstate the ground. Offshore pipeline. Pipes are welded together in the boat's hull and fed out the back of the boat via a stringer as the boat moves forward. The welded pipes form an S shape as they fall to the seabed. Steel circular tanks. The tanks are constructed using the jack-up method. Curved steel plates form the wall rings. The tanks are used mainly to store fuel. Pipe racks in gas processing plants. The pipe racks carry pipes and cables. The pipes contain gas and liquids that are transported to and from the different processes. Pipes are welded together and inserted on rollers into the pipe rack. A temporary hanging scaffold is placed below each work level as a platform. Heavy crane lifts. Prefabricated tall standing vessels or columns are lifted from the horizontal position and rotated into the vertical position using two cranes. Shown are cranes used to build a seaport. Crane lifting a 200-ton roof truss. Quarries and aggregates production. Rock is extracted by drilling and blasting. Blasting is used to loosen and fragment the rock so it can be loaded into tipper trucks which transport it and tip it into the primary crusher at the crushing and screening yard. Using a series of crushers and screens, connected by conveyor belts, different size ranges of aggregates are produced and then transported to the asphalt and concrete batching yards on site. Concrete batching plants operation. The on-site concrete batching yard comprises 2 batching plants with mixers, silos, aggregate bins, conveyors, and control equipment, where the ingredients used to produce concrete are mixed before being transported to the work site. Concrete in situ piles. Using a temporary casing to support the drilled hole. The casing is pushed into the ground using a vibrating hammer. The casing is driven into the hard stratum so the borehole will be stable and will not collapse. The ground inside the casing and below is drilled out. The bottom of the hole is cleaned using a drilling bucket. A reinforcement cage with spacers is placed in the borehole. Where the borehole is unstable, bentonite is used. Concrete is pumped into the borehole using a tremie pipe and crane. Some piles are load tested using concrete blocks. Metro. The viaducts were constructed using the span-by-span method with U-shaped precast concrete segments, erected using a self-launching gantry. Average span was 45 meters, Segments were 10 meters wide by 4 meters long and weigh 55 tons. The placed segments were post-tensioned and the cable ducts were grouted. Temporary site facilities comprise of accommodation camp, offices, plant and equipment yard, fuel farm, training facility, stores, concrete batching yard.